So, week 11, hard for me to believe, but I'm trying to believe it. So, week 11, Google Slides, and today we are going to try and see if we can walk through three important vocabulary terms that really we probably should have already walked through, but that's why we're going to them right now. And um, our main focus today is going to continue with distributed property. I'll show you that in a minute. Then after we do those vocabulary terms and a few examples, we will just give the rest of the time for you guys to tackle this Alex assignment, which is a 12 problem assignment. Hey, Gadisa, thank you so much, sir. All right, so if I go backwards here, we got two learning intentions so far this week anyway. Our real focus today is this learning intention 1, which continues our distributive property fun that we started last week. We've pretty much done this. I can distribute a factor into a quantity. A factor is just numbers being multiplied together. So when we say like 2 and 5 are factors of 10, 2 and 5 are factors of 10, that just means I can multiply 2 times 5 and get 10. So anytime we say factor, it's numbers being multiplied, and that's what we were doing last week, taking a number that was right outside the parentheses and distributing it into that quantity. Then we just want to make sure we're cool with understanding exactly what a coefficient is, exactly what we mean by like terms, and how we go about combining like terms. And then as part of that, we want to make sure we know what the simplest form of an algebraic expression is and how we get there. All right, so that's our learning intention with distributive property and the related success criteria. Learning intention 2 continues to be I can solve multi-step equations. And I won't run through the success criteria. We have done that before. You're welcome to read through those for yourself. Any questions at the moment, guys? Did Mr. I don't think Mr. Blake's put it up yet. He's been putting in the chat. Oh, no, that's because it's already passed. The Monday music during lunch, but lunch is gone. So what good's it going to do to announce it now, unless you put it in your memory till next week?
Yeah, next week.
See, Mr. E gets in his routines, and then something goes wrong when the routine goes awry. But while we're talking, Mr. Blake and City Year and all, make sure you're taking advantage of them. They're available every day after school from, is it 2:45 to 3:30 or 2:30 to 3:30? 45? All right. So 2:45 to 3:30, and of course on Wednesdays from 12:30 to 2:30. Hey, there's the announcement that we all missed already, but next week we can do it. And that same Google Classroom is a good way to get to the tutoring if you desire. City Year's making it all happen now, trying to give us a little more life than just these classroom experiences, you know. All right. If we don't have other questions right now, let's take a look at these slides, which are actually from your McGraw-Hill textbook, which we get to through Clever. If I run down here the third slide real quick, you see there in red, it's saying if you want to see more information, more supporting information, more examples, go to our McGraw-Hill textbook, and the bottom line there specifies in Module 1, Section 4, what we're working on today starts with their example 3 and goes forward. So that's where this came from. I copied and pasted right out of example 3 this definition of coefficient. It is the numerical factor of a term. I just really liked it because of the way they've got the vocabulary word orange, and then the coefficient in each of these terms is in orange. So the numerical factor, the number that's being multiplied times each term, is what we call our coefficient. Down here in the bottom corner, they're showing us that if you see a variable such as y, but any letter by itself, we know there's an understood 1 there. So y is the same thing as 1y. You don't have to put the dot for times in there. You could just put the 1 next to the y if you wanted to. Likewise, when we see a variable over a number, which of course means divided by a number, we still have a 1 right there in front of that x. So we can pull this 1 divided by 2 out in front and separate it from the variable. So we realize that our coefficient, if we see x divided by 2, our coefficient is actually 1/2. Any questions about coefficient there? Jaleea's sharing with the world that she wasn't too happy with her quiz score, but she's not the only one. I was looking at that just before class and realized that there are multiple people who didn't do wonderfully. And actually, I noticed for different reasons. So don't worry, we're going to go back and make sure we repair that. I'm hoping that what we're walking through today will actually help some of that, not all of it, but some of it, I think, make it cleared up today. All right, moving along to the next term, like terms. Like terms are just terms that have the same variables, but we got to make sure we don't stop there. Each of those variables has to have the same exponent on it. That's the only way that it's like terms, and it's where we make our common mistakes. So that's the reason you see up here in the green, the 6a squared and the 4a squared. They are like terms because both of them have the letter a raised to the second power. Letter a raised to the second power. Even though the third term has the letter a, it's not being raised to the second power, so we cannot call 2a a like term with the first two terms. Okay, so make sure you're paying attention not just to whether or not they have the same letter, but also the same exponent on that letter. And then down here in the lower corner, 1 is not a like term with the 2k and 7k because, of course, they both have k, which is to the first power. Anytime we don't see an exponent, we can also just put a 1 there for the exponent. But the 1 has no letter k, and these two both have a k to the first power. And then the very bottom one, we got b to the third on this first term, 5b to the third, and we got b to the third on the last term, so that's why they are like terms. The middle one has a b, but not with an exponent of 3, so it is not like the other two. Whoops. Any questions there? All right, so before we go to our last vocabulary term, just since we're talking like terms, when it comes to combining like terms, we're really using the distributive property in reverse. I don't normally focus on that when I'm doing like terms, but just to show, when we go to combine these two like terms, 6x and 2x, what we're basically doing is undistributing the x out of it. So, because you could think about this as x has been distributed into the quantity 6 plus 2. So now we're pulling it out, and that allows us to go ahead and add the 6 plus 2 together to get that 8x. As I said, I don't usually focus on the fact that that's got anything to do with the distributive property, but it does. It's good to at least be aware of that. When I'm combining like terms, I'm normally just saying, okay, yep, they got the same letter and the same exponent, so now we can add those coefficients in front of them together. Any questions? If not, the last idea is the simplest form, just making sure that we know when it says simplify the expression or put it in simplest form, how we go about doing that. An expression is in simplest form when it is replaced by an equivalent expression having, and it's really two things that it's not allowed to have. One thing it can't have is like terms. If there are still like terms, then we want to go ahead and combine them before we can call it simplest form. Hey, Dion, good to see you, man. So no like terms, and the other thing is no parentheses. That's what makes it simplest form. All right, so up here we got 6a squared plus 4a squared plus 2a, not in simplest form yet because there are these two like terms, but as soon as we go ahead and combine those two like terms, the 6 and the 4 make 10 of those a squared. So now 10a squared plus 2a, no like terms, no parentheses, so it is in simplest form. Down here we had some parentheses going on, pretty easy to get rid of because we can just do 3 plus 2 is 5. Now we don't need the parentheses anymore. And the 5 in front of the n, take away 7, no more like terms, no parentheses, so it's in simplest form. All right. So straight out of your textbook, just trying to make sure we know these basic ideas because we'll use them a lot from now forward. Yeah. Thanks, Julia. You are kind. And Dion. All right. So we're going to look at a few examples now, which aren't already in your slides. So I don't know if you want to take any notes on them. They are, again, straight out of your textbook. Uh-oh, just realized I didn't go back and take all my hard work out of them. So, you can just chat among yourselves. Do it quietly, though. Don't talk so loud that I can hear you from my desk. So whisper to each other at your desks. All right. All right. Oh, how I miss those days. Can't wait to get back to them. Thanks for your patience. I'll get here in just a moment, I think. If you don't already have Alex up, you could pull it up while you're trying to patiently wait on me, since that's what we'll be doing after we finish off these examples. All right, we're almost here. Whoops. Come on. All right. We can do it. All right, gonna share these other examples with you. All right. So I actually pulled this up on the computer and just took a photo of it. That's why it looks a little funky there. So this is, as you see in my handwriting up there, this is actually extra example 3 right out of the textbook. And what we're trying to do is find the correct answer between A, B, C, and D for distributing this 7 in the expression 7 times the quantity 3W minus 5. Which one of these is correct? And though we could just find the answer and then look for the answer, I just want to pay close attention to what we would expect to be going on. So in this expression, 7 is what's about to be distributed. And so it's going to be distributed into 2 terms, this 3W, and of course, Mr. Reed thinks of that as a -5 normally, but that is harder for me to talk about with this multiple choice. But anyway, that means I need to see 2 terms, both of them being multiplied by a 7. And it just so happens here is 7 times that first term and 7 times the second term, 5. That right there is exactly what should be happening. And so I'm going to say that's the correct answer. Let's quickly look at why the others don't work. So on letter B, I see that 7 is being multiplied times 3 different things, but our original problem only had 2 terms. So there should only be 7 times 2 different terms. That's why letter B is definitely can't work. Letters C and D have the exact same problem as each other, and that is that 7 only shows up once in C and once in D. Each of them do not distribute the 7 to everything. Instead, they only apply it to one of the 2 terms. And that's the common mistake with the distributed property. We multiply it times 1 term, and then we forget to keep going to the other term. So just be careful with that. So C and D are what you want to always be on guard about. Okay, I'm distributing. Okay, I got to make sure I don't forget any of these terms inside the parenthesis as I multiply. Any questions? All right. I'm trying to do these examples with my mouse instead of my tablet. A little crazy. All right, here we go. Example 4. This says distribute from the right. And you can probably look at that problem and already see what we're talking about. But up here, this was from the left. And really from the left is probably what most of us are used to doing, where you've got your number on the left side of the parentheses and you distribute it into those parentheses. Here we've got our number on the right side of the parentheses. And the only reason I wanted to do it is just to make sure everybody realizes it does not matter that it's on the right side of the parentheses. We can still distribute it. And as my little reminder or justification, if I come over here and talk about, well, 2 times 3 is 6, I think we probably all know that you can turn that multiplication problem around and it doesn't affect the answer at all. It's what we call the commutative property. The order in which we multiply makes no difference. Therefore, since I got this big quantity times 6, I just feel like putting my 6 out front because, gee, that just feels right. I think that's the case for lots of us. Just feels correct to have that 6 out in front. So now I'm just going to go ahead and distribute 6 times the 3y squared. And I'll go ahead and write that. You know, the way I usually deal with the distributive property is I think about it as however many terms are inside the parentheses, I'm going to have that many multiplication problems. So that's what I'm writing out right now. My second one comes from doing that 6 times a positive y. So here we go, 6 times y. And I'm writing it out a little longer than we would have to, but just trying to make sure we can clearly see it all. Don't forget, in Mr. Reed's mind, that's a -8 because of the subtraction sign in front of it. So I'm going to multiply 6 times -8. So there's my 3 subtraction problems from which I will find out what sign goes in front of each one. The 6 times 3y squared is 18y squared. It's positive. And then the next one is 6 times y, or 6 times 1y. If you're like, well, how do I figure that out? Well, that's 6 times 1 is 6. But that's definitely a positive 6y. And then the 6 times -8, we have -48 as a result of that. So the sign in between them will be that minus sign. I try and keep my signs a lot more simple rather than having 2 in a row. But if you do have 2 in a row, just know that if it's 2 negatives, it's going to turn positive. And if it's 2 different signs, it's going to turn into just 1 minus sign. Okay. Any questions there? If not, we got 2 more examples, kind of 4 more, because this example's got 3 parts. It says simplify each expression, but really this is all about combine like terms. Okay, so this is 3 separate examples of combine like terms. The first one's pretty straightforward, hopefully. Those are like terms because both terms have the letter A, and though it's not written in there, they are A to the first power. So I can just do this. The 14 and the 18 are going to get added together, and we're going to keep that A. So if we had 14 A's and another 18 A's, that makes a total of 32 A's. So 32A would be my final answer. On letter B, we have 4b squared plus 9b minus 3b. And the like terms are those last 2 terms. Both of them are b to the first power. They are not like the first term, which has b to the second power. So I'm going to go ahead and bring the first term down, 4b squared. And then when I go to combine this 9b and 3b together, I can just do the 9 minus 3b. And that gives me a final answer of 4b squared. The 9 minus 3 results in a positive 6, so that will be plus 6b. Any questions? It probably wouldn't have been a bad idea for me to have brought that plus sign down as I was doing that problem. Either way, as long as you don't forget it in your final answer. All right, one more. This one, so simplifying each expression and making sure they're in simplest form, both A and B we see don't have any like terms remaining. and neither of them had any parentheses remaining. That's the two conditions. In letter C, we've got not only like terms going on, but we also have parentheses we need to get rid of. So I'm going to go ahead and combine these two like terms that are in the parentheses. I'm going to stop doing what I did on A and B where I put the coefficients in parentheses. I'm just going to go ahead and do it. I'm going to say, well, I know that 5 plus 2 gives me a new coefficient of 7 while I keep the letter M with it. And that's being multiplied by 10. We already talked about the fact that the order of multiplication does not matter. So 7 times M times 10 is the same thing as 7 times 10 times M, which makes it really clear that that's the same thing as 70M. As a final answer. No parentheses left, no like terms remaining. It is in simplest form. Any questions on any of those, guys? All right.
No sir.
Thanks, Dion. We got one more, and it's just because there wasn't anything identical to this that I noticed in the textbook examples, and this is like one of your Alex problems. So not a big deal, but we're just simplifying this expression. And so I'm going to take this -4. I just circled it so it's really clear that we have a -4 that we're distributing. When I do the -4, if you like to think of this as a 1v, that's fine. -4 times 1 is going to give me a -4v. And then the -4 times the 6, -4 times +6 is going to give me a -24. Okay, so I don't always write those separate multiplication problems down if I can handle it in my brain or on my calculator. Then I have to make sure I don't forget that we have a plus v. It's not in the parentheses, so I won't distribute the 4 to it. I'm not done because I have two like terms here. We've got a -4v, and of course this is a 1v. So to finish this problem, I need to combine those, -4v plus 1v. So bringing that term over here, I could again put -4 plus 1 in parentheses, but instead I'm just going to go ahead and write the answer, which is -3v. And there's nothing to combine that -24 with, so I will just bring it down. And there's my final answer. No like terms, no parentheses, so I am done. Okay. Did anybody need any clarification about anything? I tried to do that one a little bit faster than some of the other ones I was doing, but if that left anybody confused, please ask. All right. Well, we will allow you guys to work hard for the remaining almost 15 minutes, 13 actually, 13 minutes to see if you can get close to having your 12 problems done.